Okay, today I'm going to give you a demonstration of my latest project in my retirement, which is a microcontroller based AC power meter. I'm pretty proud of this one. So here's what it looks like. It's got an OLED display. It's made out of an electrical plastic dual ganged electrical box. There's my input power, and that's where I plug the load into. And it'll display the power on the front. So I'm going to go ahead and plug it in and see if it works. Okay, so I've plugged it in. It's displaying 117 volts and no amps, no power yet. So I'm going to open it up, have a look inside. Down in the bottom is the PZEM module. Connected to that is the ESP8266 D1 Mini. And that's my OLED display up there. So it really worked out good. This this box cover, a dual box cover, with one blank on one side and a switch opening on the other. Right. This here is a blank, so it's got the wider screws. Anyway, it worked. It was a really good way to do it. Okay, so down in here, if we look, the bottom is the PZEM module, the circuit board, and this thing here is the current transformer. And you have to pass one wire of your line load connection through there. You'll see it on the schematic. And this here is the AC input DC 5-volt output module, which is really handy for these kind of projects. So that's pretty well everything inside the box. Now I will demonstrate how it works, and I'll plug a few things into it. Okay, I've got three things plugged in now. I've got a electric drill, a heating pad, and a soldering iron. So let's have a look. Right now the heating pad is on, and it's showing it's using 0.4 amps and about 46 watts. Power factor of 1 because it's a purely resistive load. So I'll turn off the heating pad, and I'll turn on my soldering iron, and it's using 138 watts, 130, and a power factor of 0.94 because it's got a transformer in it, so it's not a purely resistive load. And if I run the drill, you'll see power factor. There's the power factor of 0.39 there, 70 watts with the electric drill. Now the cool thing is I'm also using the REMOTEXY on my phone, and you can see the power graphs of volts, amps, watts, and power factor. So let's turn on the electric heating pad, and I don't know if you can see the wattage. It's 0.4 amps, 46 watts. And a power factor of 1. I'm going to add the soldering iron, and you'll see power factor should drop down a little bit, 0.97, because, yeah, it's mostly resistive. Let's turn off the heating pad and turn on just the soldering iron. We've got 0.93 power factor. Let's run the electric drill. 0.3 power factor, yeah, okay. Anyway, so I'm pretty happy with my power meter. So, any questions, send me a message.
Okay, so a friend of mine said I should do an instructional video, and I'd get a lot more hits on my video channel. So I thought, okay, I want to do that anyway. So I went through the effort. I think I'll start with, this is the physical schematic. Hopefully you can see that okay. So we've got power, AC power line and load. and when you buy the PZEM module, you get this current transformer as well. So you pass one of the wires through the current transformer so it can measure current. Hook it up to the AC, ground, DC ground, 5 volts from my good old H high link module. This thing was really neat. You put in 5 volts, or you put in 120 volts AC, and you get a nice 5 volt DC output. Great for projects like this. So the PZEM module needed 5 volts. The D1 Mini, I supplied it with 5 volts. Then it supplied the 3.3 volts to my OLED display. So anyway, I'll put this schematic in the comment section as well, in the description, I mean. Okay, and as I've been doing with all of my projects pretty well, I use REMOTEXY. This is such a great tool. It's a web-based development, and here's my projects. This is the one I use for this WeMOS Power, I call it. So you just drag your controls onto the screen. You can use up to 5 for free, so which is great. That's all I ever need is 5 controls. So anyway, these are the online graphs. You can do digital displays. You know, you can do all kinds of things. I've only scratched the surface on them. So you pull them onto your screen and size them up and everything. So that's the way you do your GUI, your user interface for your phone. I think it supports Android and Apple. And then when you're ready, you link these to whatever the variable name in your application is going to be. So in this case, this is volts. So there's the variable there. It's going to be called volts. This one's called amps, and so on. Okay. You also specify, how you're going to connect to this thing from your phone. You can use Bluetooth, Wi-Fi. You can go direct wired. Anyway, I use Wi-Fi because I use ESP8266 boards. They're the cheapest pretty well you can get, cheaper than ESP32. ESP32 has Bluetooth. These guys don't. But Wi-Fi works great. And I did a different video where I was demonstrating REMOTEXY as well. Okay, and then when you're ready, you go get source code, and it will produce the source code that you need to include in your Arduino project. Okay, so this here is the user interface into my Arduino, which at runtime, the phone app, REMOTEXY app, grabs this code and builds the user interface. Really, it's really amazing, and I highly recommend it. Try it out. If you have any questions, send me a message. It's fantastic. I really like this tool. Okay, enough of that. Now, next thing I'll show you is the Arduino code. I'll include this as well. Okay, so there's some code in here for my OLED display, for my REMOTEXY interface, for the PZEM module. Anyway, they're just libraries, right? The first part of this is to do with the Wi-Fi stuff. Here's that code that I pasted in here from REMOTEXY, right? The user interface. These are the REMOTEXY variable names, volts, amps, watts. That's what I named them when I built the GUI. And that's the end of REMOTEXY include. Okay, so just looking at the code, this is the PMZed examples, and I'm using D5 and D6 on my microcontroller. And this is OLED stuff. So really building applications now just involves grabbing code from different people, different libraries, grabbing the libraries and putting it all together. So so right here, this is my PZEM module. So I get voltage from the PZEM module and put it into a local variable called voltage. And then down here, I take that voltage and I assign it to the REMOTEXY variable volts. And that's how the user interface gets the value for voltage. And I also display it here on the OLED display. And then I do a 500 millisecond delay. You have to use REMOTEXY delay because it's time critical, the REMOTEXY stuff. So you use its delay and go back and do it all over again. Okay, so that's instructive on how this thing works. If you have any questions, let me know in the comments. If not, have a good day.